Looks like we're up and running again. Okay, so this is kind of crash course time. Got one more class for B block and 2 for C and a couple of tests, and then Friday we're off. So how do we compare to previous classes over the years? About the same, except that you're getting 2-3 weeks less of instruction. So that's where we run up into the difficulty with these last topics. 10 minutes less per class and semesters versus trimesters, and you throw in remote learning. So when all is said and done, actually, I feel pretty good about where you're at. However, I would like you to take out of the class all of the topics that would be covered at this level. And I think we're just selling a couple of short related rates, obviously. And volumes of revolution and areas bounded by curves. And those are major topics. So we're going to try to just do justice to the cause one more time. We'll practice on Monday. Hopefully you'll practice some of the problems today with me. I left my charger somewhere, so I got 25%. So we're going to keep going here. And we'll cover volumes of revolution in this video. I'll look at how much charge I have left in the computer. And if I can't make the videos today, I'll make them tomorrow, but I'll try to upload on Canvas this one at least. All right, so here you have y equals 5, the x-axis, the line x equals 3, and y equals 7. And we're just going to find this area. Obviously, you don't need calculus. You do not need calculus. It's got a width of 4. What did I write y equals 4? X equals 7, sorry. 4 for a width, 5 for a height. We know the area is 20. Because we know the height is 5 and the width is 7 minus 3. Okay. Now, how do we do it with calculus? How do we do it with calculus? We've been talking about top minus bottom. The bottom is the x-axis, which is y equals 0. Right, that's how we determined it's still top minus bottom. Probably brain didn't have to do that. It did it automatically. But when we're going to have more difficult situations, brain's got to do that. Okay, so width. Well, what are the widths in calculus? The widths in calculus are dx. In other words, we're doing this. And how many of them are we doing? All of them. To the point where this is a Riemann sum of millions of rectangles. And boy, you want to do billions of rectangles, you just eliminated some error. Although there's no error in this because every single one of these fits nicely. We could do this with a 1 Riemann sum, left or right. Okay? No approximation in this. And so what do we get if we do that? From 3 to 7, that kind of tells us, you know, we're expressing the width here, really. Then what do? You integrate. And then you do the parentheses minus parentheses. 35 minus 15. Lo and behold, it's 20. Now that's called doing the integration in terms of x. So many of you underneath the first problem on part 2 test had y values all over the place. And if you're doing it in terms of x, that is something you want to consider immediately the next time we take this test, which is Tuesday. Part 1 we'll do Thursday because we made a lot of gains on part 1 from a week ago last Thursday. All right, there is no better way of learning this than to have the marker in your hand, you trying the problems, and then talking to your mates if you make a mistake or helping someone who made one. Okay, and we haven't had enough of this because of remote learning, and it's a short term. But when we did put some time in a week ago on a test that chain rule, product rule, quotient, were not in place, I noticed that for the group, the next week they were in place. We want to do that here now. Okay, so that's this integration. Now, what happens if y equals 5, let me get an eraser here, becomes some function? of x. Not that that isn't a function of x, but a different one. What if it becomes something, like that? And we call this f of x. Not much different. That's it. That's it. And what if the bottom became something different? Let's call it g of x. What if you were at 7 and then you were at 1? Well, I think, it's not 7, it's not constant. So it would be just this one rectangle. Well, that one rectangle was at a height of 7 and a height of 1. Well, I think we would assign 6 to that altitude. I think we would assign 6 to that altitude. Okay, the others would have different assignments for their altitude. But what would we have? F of x minus g of x. dx. Now, it might not be this anymore. No, certainly not going to be that anymore. We could certainly figure out what it is, right? F of 7, big F of 7 minus big F of 3 minus big G of 7, G of 3, whatever. Okay, but top minus bottom. That's area. Now, if you'll notice, finding that area had nothing to do with the letter pi. Nothing to do with it. No pi r squareds. It was just area. Right? Just length times width. Now, if we wanted to make it into some kind of revolution, going around the board, taking that area and swinging it around, well, we're going to do it differently now. All right? The washer method is a shortcut way of writing something, just like U substitution. It gives you a shorter way of doing a definite integral, where you don't have to come back to x. So the washer method is pi a to b big R squared minus little r squared dr, depending upon whether you're doing x's or y's. We're going to do it as two disks from now on, because that's really what that is. But we're not seeing it. We're not seeing it. So let's just look at square root of x. And let's rotate this around the x-axis. So we have a dx here, right? So we're going to go from 0 to 10. No, 0 to 9. We'll keep the numbers nice and easy in case we do it out. Okay? So we're going to take this area and we're going to rotate it. And if we do, that's what it's going to be. It's going to be a solid revolution. And the top is x and the bottom is 0. That's the area right here. We're going to rotate it. Okay? Okay, so I don't have, I have a lid here. Let me get a lid off of the coffee cup. All right, so let's get that lid in here. Don't spill anything. So that lid looks like it fits right about here. And if I would slot that, the x-axis through and push this behind the wall, then we're defining this. And this has volume. It's got area of a circle with a little bit of thickness. What is the thickness? The thickness is the radius, which has a dx. A dx thickness. Like right here, maybe it's right there, maybe it's 2. Right there, maybe it's 2.01. But I have moved a little bit horizontally. That's what we call dx. So this is called a cross section. It's made up of pi r squared, the area of the circle with a little bit of thickness. And that's called a disk. When we rotate this, we take the pi out. And there's your pi r squared with a little bit of thickness. From what to what? Well, in this case, 0 to 10. Now, what is my radius? Well, it's the square root of x. That's a disk. We can make a cylinder. What's a cylinder? Pi r squared times height. Pi r squared times height. So let's do one of those. Let's see what we get for volume. We'll make ourselves a can. What's y equals 10 is nice round number. Let's rotate from 0 to 5. So just from there to there. Rotate. There, it's my best drawing. Better than normal, but I guess, let's see, if it was, I don't know, best I can do. So what are my heights? Well, my heights are always 10. What is my cross section? Pi times 10 squared. What am I going to do? I'm going to do that over the width, 0 to 5, which really gives us the height of the can. And I believe I'm going to give it a little bit of thickness. And I think we can probably do this. Looks like it's 10 squared is 100, so that's 100x times pi from 0 to 5. So that's 500 pi for volume. 500 pi, I don't know, centimeters cubed, whatever, 500 pi. Okay, so let's go back to our formula. So volume equals pi r squared h. Well, r is 10, so that's 100. That's pi, and h is 5. Boy, it matches up with the geometric formula. So what happens if this is f of x? What's my altitude? F of x. What am I going to do? I want that to be pi r squared, so this has to be squared. And that's a disk. What if I wanted to do another disk? Let's do g of x. Let's not do f of x. Let's do g of x. I think it's the same. I think it's pi, 0 to 5, g of x. I'm going to put that in parentheses and square it dx. I think that's this little area rotated. Well, what if I wanted to find the volume if we took this away from, if we took this disk out of? Wouldn't I create something that looks like a washer? It's got a hole in it. So how are we going to write these from now on? Exactly what I said. We're going to take g of x. There's my first disk, my big one, my outside edge disk. Here's my inside edge disk. I'm going to rotate it around this axis. So I'm just going to subtract pi 0 to 5 g of x squared dx. Okay? And that's the washer method. Now, the washer method could have been written for those of you who understand this and whatnot, but I'm suggesting, because most everybody got it wrong. I think there were 48 possible correct answers, and out of 48, 2 people, I think, got one right in class B. That's got to come up. So I think we're looking at pi 0 to 5 f of x squared minus g of x squared dx is just bringing these two things together and writing it in a shorter, more succinct fashion. All right, so let's give you one to do. See if we can write it, I think, as a subtraction of disks. Get a cleaner board here. That was pretty messy, but I don't have a lot of charge in that computer. I'd like to get quite a few practices in here. Upload this, get you started. I haven't corrected the C block test yet. It's got to get to that. All right, so let's look at a function here. Let's look at, how about we look at y equals x squared. And let's look at y equals, how about 6x? Okay, so we got 2 functions. And we're going to rotate this area right here around the x-axis. Okay, we're going to rotate that around the x-axis. So you pause the video and you try. Well, obviously, you got to solve 6x equals x squared. We can, by inspection, see that that's 6. All right, so we are going to go from 0 to 6. That much we know. And we know we got volumes of revolution, so there's a pi. We're going to do the big disk first. The big disk has the outer edge. Well, that's this. That's the outer edge. That's this function. I got a pi r squared that. I think I'll just do that. Just take 6x and square it. Dx. All right, so that's a solid of revolution. Now I got to take away the interior disk. I got to take the interior disk away. So what's the interior disk? Well, it's got a pi. It's got a 0 to 6. And I guess I got to have variable radii, whatever. And that is the lower. So that's x squared squared. I'll write it x squared squared this time, dx. You're done. Okay, done. Now, how do these problems change? The only level of difficulty in terms of x. Now, terms of y is a little harder because you're used to doing functions in terms of x. You know, you're used to taking x numbers and working with them to get something, some new number. Well, next problem, you're going to start working with the y values. I think I'll use this one. This is a nice one to use. So we'll do it in terms of y in a minute. All right, so let's rotate around about y equals -10. Okay, well, that's a much bigger solid. Let me get rid of this. All right, that's a much bigger solid. Let's see if we can try to draw that. So all I'm working with is 6x, and I'm working all the way down here. So it's going to look something like that. That's a big solid revolution. All right, so I'm still going from what to what? I think I'm still going out here to x equals 6. Is that what we said? Yeah, 6 squared. Yeah. And so now this doesn't exist. That's not my axis. My axis is down here. So then the question is, what are these distances? What are those distances? I think this is where we got to do top minus bottom. 6x minus a minus 10. Obviously 6x plus 10. How do I make this a volume of revolution? Pi r squared. It's in terms of x. How do I figure out what the height of this container is going to be? Oh, 0 to 6. I'm done. Now, what if I want to take out some of that volume? And we'll use x squared. Well, it's not here anymore. That's gone. We did that. So now the question is, what's this disk? I think I'm going to subtract. I got enough room here. Subtract. Okay, I'll keep an eye on the camera. Let's move it a little bit this way. No, it's got everything. I got the border over there. I think it's another pi r squared. I still think it's 0 to 6. Then the only challenge is the distance of the radius. Wonder what that could be. Oh, top minus bottom. And minus a minus 10 is plus 10. X squared plus 10. Well, there's my pi r. Oh, volume's a revolution. Pi r is not the area of the circle. Pi r squared, area of the circle, dx. That's it. The only other thing that we do is we might rotate around y equals 50, right? Then what happens? Well, then the edges change. Then the edges change because this is the bigger distance. So the distance that I'm going to create is that distance. Still going 0 to 6. Still pi 0 to 6. But we have to define that distance. And if this is 50 and this is x squared, I think we can see it. 50 minus x squared. There's your pi r squared dx. And that gives us something that rotates. I'm hitting the ceiling with that one. Yeah, I get the rotator cuff going again. And then this would be the inner one. All right, and that's 6x. So we would be subtracting, again, pi, 0 to 6. This distance, what's that distance? It's 50 minus 6x. Well, there's your pi r. Oh, area. pi r squared dx. That's it. That's what you're going to get hit with on Tuesday. Area and volumes of revolution. There are other volumes we find, but there's not enough time in the term to go after them. You know, you got to put the brakes on somewhere so that you can try to learn everything that's been presented. And we're in the midst of that, in the midst of doing it remotely, which is hard, and less time, trimester, less time per period. So the expectations are a little different, but not for me. I still want you to get everything that we've covered. All right, so keep at it. Now we're going to do the same problem, but we're going to do it in terms of y. Okay, in terms of x. Terms of x. When x is 5, 5 times 6, that's a height of 30. Okay, now we're going to start doing things where we look for these distances. All right, so let's try it. In terms of y. Everything gets labeled in terms of y. That's why I gave you 2 pictures on that test. I don't think it mattered, but maybe repetition is our friend. Repetition is our friend. So now maybe we'll say everything in terms of y. Everything. For instance, y equals 6x. Well, then x is equal to y over 6. This is a new name. It is now named y divided by 6. Y equals x squared. New name. X is plus or minus square root of y, but we're only going to deal with the positive because we're in the 4th quadrant. Square root of y. We're going to find this area. That area. Okay, which means we need these distances. And that's the square root of y, and this is y over 6. Well, let's go back to what we had before. Let's look at, what's the best way to try this? It's dyslexic. It's a little dyslexic. All right, let's look at this value here. Let's say it's on a number line because we're measuring on a number line this way now. So let's say that that's 8. And over here, this is 5. What's this distance? Distance is always positive. It's not 5 minus 8. No, that distance is 8 minus 5, which is right minus left. I'm doing it this way. Right minus left. 8 minus 5. Okay, that's that distance. So how are we going to find these distances over here? Well, it's really 2 distances. It's really, let me get a gap here. It's really the distance from there to there minus the distance from there to there. That's giving us the distance trapped. And now how do I find this distance? Well, for instance, the one we can see, I think, is up here we have a coordinate, 6, 36. And this is a distance of 6 units. That's a distance of 6 units. If I've got the y values, how would I find this distance? Yes, I think you would say the square root of 36 gets us that distance. And what else gets us that distance? Because on the line, it's the same distance, which means there would not be any distance there to compute. Oh, y divided by 6, 36 divided, oh yes, that's also 6, which means there is no horizontal length to the rectangles we're creating at that instant. Now, is there a nice place here? Yes, 16. 16's a real good one. So what is this distance at 16? What is that? We'd like to know. Well, I know what the square root of 16 is. That's 4 units. That's 4 units. And I know, 16 divided by 6, shucks. 16 divided by 6, 8/3. I also know that this is 8/3. The whole thing is 4. This part is 8/3. So what is this part? 4 minus 8/3. 12 minus 8/3 is 4/3. What's got a nice divided by 6? 24. No, that doesn't work so well with the square root. All right, would have been nice if it was all integer friendly. But bottom line is, what are we going to do? Oh, we're going to take the right. We're going to subtract the left. And we're going to do that with, oh yes, this y value right there. That might be 4.01. That y value might be, it's right here, right? That y value might be 4.01, and the one underneath it, 4.000. Well, that's a dy. That's a little change in altitude, and that's what your widths are. And now we're going to do that from where? How many are we going to do? All the way down here, starting at 0. I wonder how high I have to go. Oh yeah, we're working with the y values. That's 36. And that's how you find area in terms of y. Let me check on my computer charger. I got some more time here. Yes. Oh, let's do a disk now. Let's rotate this around the y-axis. I guess I need all of those distances. What function is getting me that? No, square root of y. Oh yeah, the square root of 36 is 6. That's right. And the square root of 0 is 0. Okay. And I want to rotate. That looks like a bowl. That looks like a bowl. I don't see anything. I don't see any holes in it. So I guess that's one of those pi r squared jobbies. Yep. Except that we're rotating this way. UFO. Unidentified flying object on the last test. All right. So, pi r squared. Well, there's my r. There's my r squared. There's my pi. From what to what? Dealing with the y values. All the x's are written in terms of y. I need a little bit of thickness. I'm done. Let's do the disk. Y over 6. That's going to look like this. Well, that looks like an athletic cone. Not a very symmetric one at that. Oh, that's pretty bad. That's a little better. Whew, still 36. Looks like that one has a pi. Woo, with a radius. With a radius squared from 0 to 36. A little bit of thickness right there. And that gets me that. I wonder if I took this away. I wonder if I would then get this rotation. If I took out the center. I wonder how I could take away that disk. Oh, take away a minus sign. So I guess all I had to do was take out the pi 0 to 36 y over 6 squared dy. And I got a washer, a Dunkin' Donut. Now, what happens if we didn't want to rotate it around the y-axis? What if we wanted to rotate around an axis maybe to the right here? Let me make this a better picture than this. This board is not very clean. Okay. Oh, I wish we'd get the old erasers. Too much here. Come on, baby, come on. There we go. Come on, nice and clean. Oh, God. Oh, so let's go around x equals 10. Over here, we got ourselves the y equals x squared, which is x equals square root of y. And we got y over 6. That's right. We're still going to go to 36 and we're still going to go to 0. What's the big distance? Is it from here to here or from there to there? That one bigger than this one? No. So let's erase that and let's just do a disk. And that disk would look like this. Boy, that looks like something out of a sci-fi movie. Paper airplanes we used to make in middle school. All right. So there's your big distance. And I forgot how you measure distance. Oh yeah, right minus left. 10 minus y over 6. Well, there's your distance, but I think we have to pi d square this, don't we? I think we have to pi square this from what to what? 0 to 36. We're doing it in terms of y. Oh, I need a little bit of thickness. But we're going to take away the disk. We're going to take away that disk. Yeah, I guess that's good enough. Good enough. Yeah, we're going to take this space out, which means that really this is the volume that's going to remain. And if we spin that around, I'm not even going to try. Yeah. Oh, God. Yeah, I think we get something like that flapping around this axis. A sphere of some kind with top and bottom flat. Sits right on the ground. Oh, yeah, we're just taking away this disk. I don't want to get that in the way of my thought process. And that was the square root of y. So we got to figure out that distance right there in terms of this y value. Boy, I know in terms of this y value that is the square root of 36, which is 6, and this is 10. I got a feeling that's a unit of 4. Yeah, this is 10. That's that x value is coming from the square root of y. That x value is coming from taking the square root of y. I think it's minus. I think we got one of those pi r squareds. And I think from 10 to, I think that's 10 minus the square root of y. There's my pi r. Oh, I want pi r squared with a little bit of thickness from 0 to 36. That's what you're going to practice on Monday. All right, worksheet. I'm going to throw 2 problems your way. You're going to try them on the board. And if you don't look at this homework and it's the first time you see those 2 problems, give up. You're not going to have enough time probably unless you come to Math Help. Spend all night Math Help Monday night, right? But if you look at the video and you think about it, you practice a couple more on Monday. Okay? But we're also going to practice related rates on Monday. And there was one other that was very troublesome. The ladder problem, right? That's related rates and area of a circle changing when its radius is changed. So those 2 topics are related rate topics. So we're going to cover that too. So it's a lot on your plate. Yeah, it's a plate, by the way. Circular. It's got a little bit of thickness. Okay. You're going to have to put some effort in here. All right. So I'm going to upload this, and I hope you look at it, and I hope you replay it. I hope you think about it. It's last shot. Last shot is Tuesday. I would do it Thursday, but I think we got to do it. We're hot on the trail of this stuff. You just found out. You got no clue what you're looking at. I understand that. It's not easy stuff. It takes time to learn. You better put the effort in right now on this video. Replay it. See it today. See it tomorrow. Practice it Monday. Come in Monday night to Math Help. Tuesday, got a shot at it. All right. Hope you can do it. All right. So I'm going to upload this now.